My name is Mostafa Nadri. I am expertise in hydrogeology and work in the Department of Earth Science in Institute for Advanced Studies and Basic Sciences of Zanjan, a city located in northwestern of Iran. I want to talk about the assessing level of management in river and groundwater. Okay. As you can see in this picture, this is the river that flows over the land, and so it should provide two functions and and support two main sectors that including the ecosystem. So some portion of water in the river should be left for supporting the ecosystem and all flora and fauna lives in this region. And and remaining portion of water that flows in the river for human water use, directly or indirectly use. For example, for domestic water uses or industry or municipal consumption. So the river has two main functions: supporting the ecosystem and supporting the human water use. The groundwater also is another important water resource in the regions, especially in arid and semi-arid regions where the river doesn't exist to support the ecosystem and human water use. But the groundwater can flow within under the ground and also support the ecosystem, and the portion of water in the groundwater resource is directly used by the human using the drilling wells that existed in groundwater. So the groundwater, some portion of water in groundwater flows to the river, known as base flow river in hydrogeology or hydrology science, and a portion of water can be used directly by human. The river functionality that depends on the type of ecosystem and the population of the human that uses the water in the river. So the type of ecosystem determines the volume of water from a river that should be left for water-dependent ecosystem. But the groundwater that meets the demand of ecosystem depends on its hydrogeology. Okay, here is shown that the groundwater level is higher than the river water. So groundwater can flow through the river in dry season or all during the time of the year, and support the ecosystem. So the groundwater indirectly support the ecosystem when it flow into the river, and then usage and then it is used by the flora and fauna that exists in the region of interest. But another situation is emerging the springs. When groundwater table reach the surface and contact with the surface ground, such as shown here. So the groundwater can flow out from the subsurface without as immersed spring, and then it can be used by the human and ecosystem. So the water resource has two main functions. One portion need to be left for ecosystem and a portion left to be for human. Okay, until now, the hydrogeologists and hydrologists assume that the total volume of water that exists in the water resource totally can be used by human. And, on the other hand, there was no metric to quantify the level of management. And until now, all hydrogeologists describe the management of a water resource cannot quantitatively describe the level of management, and they report qualitatively as weakened or best. For example, this groundwater level, that is a documented case of groundwater depletion in Cook County in Georgia, show that the groundwater level from this year, 1967, decreases gradually and continually until this year, during about 35-year period, and the groundwater depletion and related decline water table by about 15 feet. So we can only say that the management in this aquifer is weakened, but the level of management cannot be answered. This is another example for Jahrum aquifer in southern Iran, located in an arid climate. This is the groundwater level that show from 1998 decreases rapidly, but then decreases in a lower rate. However, from 1998 to 2012 year, the water table has been dropped by about 15 meters. This is the 5-year moving average of the precipitation in the region. As you can see here, the decreased precipitation cannot be the main factor for decreased or declined water table, and it is concluded that another factor must be incorporated to this declining, and it is overexploitation, groundwater overexploitation. Okay, but until now we cannot say that what is the level of management in this aquifer and what is the level of management in this year, but what is the level of management in this year. Only we know that the management in this aquifer is weak. Okay. Let me to explain the concepts of water availability and supply. Assume that this is the total volume of water exists in a water resource, such as river or groundwater. As I mentioned before, some portion of water must be left for the usage of the ecosystem. So this is the volume of water known as EFR, environmental flow requirement, that must be left for the ecosystem. Okay, so the total volume of water minus EFR reveal the available water. So the available water is the volume of water that exists in the water resource that can be consumed by the human. Okay, so this picture show the water use in different sectors, for example, in agricultural, municipal, or industry. The net volume of water that a sector requires to produce goods and provide services referred to as water demand. So When we want to transfer the volume of water from a water resource to the region of interest to meet the water demand, some volume of water losses during transferring. So we need to support and supply the volume of water at least greater than the water demand to meet the volume of water demand in the region of interest. Assume that this is the volume of water demand and this is the volume of water loss due to the transferring. So we need to transport and transfer the water by this volume from the water resource to the region of interest to meet the water demand in different sectors. Okay, so we can use the ratio of available water and water supply, as a physical metric to assess the level of management, which I will speak about it in next slides. But the factors may affect the management, the water management is or development in industry and agriculture. Development in industry and agriculture increase the water demand, and so we need to larger volume of water to supply. Population growth that likely increase the water demand. Water over exploitation. For example, in some area of Iran, no increase in agricultural area is not a guarantee to doesn't increase to no increasing water over exploitation, because farmer may their farmlands with over irrigation. However, the farm area remain unchanged. Another factor is land use change or cropping pattern that depends on the type of crops, in which crop with low water demand is planted or crop with higher water demand is planted. Water use efficiency that controls the volume of water loss. As the water use efficiency increases, the volume of water loss is reduced. So increased water use efficiency decreases this water supply. And the most important and interested factor may be the climate change. Okay, level of management. So the level of management can be calculated for a river using this formula, in which this is the available river water minus total water supply to available river water at the initial. So we can say that the LOM represents the residual volume of water after supporting the ecosystem flow requirement and water used by humans. And again, the LOM for groundwater defines similar to that for LOM in river, available groundwater minus total water supply to the available groundwater, initial available groundwater. But the available water defined in river and groundwater differ to each other. Available river water using the presumptive standard method reveal that show that about 80% of mean annual river flow should be left for sustaining the environment, and only 20% of the river flow can be used by humans. But as I mentioned before, available groundwater, which is defined as the total recharge minus EFR, and EFR depends on the hydrogeology. In some situations, the EFR may be 0, and available groundwater can equal to the total recharge. So generally, we can say that the LOM in a water resource represents the residual volume of available water after supporting the ecosystem flow requirement and the water used by human. Okay, as a case study, I use this metric for a region in northern Iran where 9 sub-basins or 9 rivers flow to the international wetland of the Anzali. This is the wetland. And also evaluate the level of management in the groundwater, that the boundary of the groundwater, the aquifer is shown by a red line here. Okay, rivers LOM in percentile. As you can see, the monthly level of management, the level of management in subbasin 1 and 2 is 1 during all months because no abstracted water from the river. So total available water after supporting the ecosystem flow requirement and human water use is equal to the initial available water. So the LOM is 1, which is an ideal value. But in another subbasins that the river is abstracted for human use, the LOM is low during dry seasons and high during wet seasons. Okay, but base A and base B denotes the scenario when base A show the level of management under the available water use efficiency, and base B show the level of management under the improved water use efficiency. The agricultural water use efficiency is about 20% across the region, but in scenario B, base B, assume that the agricultural water use efficiency is improved by about 10%. That is, increases from 20% to 30%. As you can see here, the 10% increase in agricultural water use efficiency increases the LOM in during these months, because increased water use efficiency leads to reduce the water supply and abstracted water from the river. And this is the picture for mean annual LOM across 9 sub-basins. Again, for base A under available water use efficiency and base B under improved water use efficiency. As you can see, some sub-basins, for example, sub-basin 3, 6, 5, the LOM is negative, which means that the volume of water that extracted by humans is greater than the total available water. So some portion of water that supported for human is originated from portion of water that must be left for the ecology. Consequently, the ecosystem in these subbasins are under water stress. In the literature, these subbasins can be referred as hotspots. But in the positive, there is no water stress on the water-dependent ecology and ecosystem. But in scenario base B, which is assumed that the agricultural water use efficiency is improved by 10%, the level of management in each subbasin increases from, for example, in this subbasin 5, which is the LOM is negative value of 1.3, increases to negative value of about 0.77. The groundwater LOM in present time for the Fuman aquifer. As you can see again, this is the monthly LOM in groundwater under the available water use efficiency. in some region, in some months, the LOM is positive, but in dry seasons, the LOM is negative. However, the improvement of the agricultural water use efficiency increase the LOM, but cannot increase the LOM at such level that can be acceptable for management. This is the mean annual value of the level of management in groundwater in scenario base A show that the mean annual value of the groundwater, the level of management in this aquifer is near zero, which is show that the total volume of available water is extracted by the human. So there must no long-term water table decline that evidenced by the observed data. But increase in water use efficiency improves the level of management and can increase the level of management and at acceptable level when the level of management is positive. Okay, I further assess the effect of climate change on level of management. Here you can see the annual temperature in two synoptic stations and precipitation, annual precipitation that is downscaled under 3 global warming scenarios. SSP1, which is the best scenario, SSP2, which is the modest, and SSP5, which is the worst case. From the downscaling results, it is concluded that the study area will warm from about 1.4 degree to about 2 degree under different level of global warmings. And the precipitation also decreases by 3% to about 12%. The more as the study area will warm larger in degree, the temperature, so the precipitation, the reduction of precipitation is greater. Okay, again, reverse LOM under climate change. This is the available water under the present time. For example, for subbasin 1, which is about 0.4, but decreases to about 0.25, 0.24, 0.21. And this is happened for other subbasins. Consequently, assessing the effect of climate change on river flow show that the available water will decrease in the future due to climate change, in which the climate change was reduced precipitation and increased temperature. As the precipitation decreases, so and available water consequently decreases, the LOM is expected to be decreased. Again, for example, in subbasin 5, the LOM decreases from minus 1.3 to about minus 1.7, minus 1.8, and minus 1.95. But the improvement of water use efficiency increases the LOM even under the climate change. When you compare the LOM for a specific subbasin, for example, for this, in subbasin 5, the LOM is minus 1.66, but this is about minus 1. Show that the LOM, the level of management increases under water use efficiency. And again, the groundwater LOM under climate change. This is the monthly LOM for groundwater. This line show the monthly LOM under present time, and the blue, green, and red colors show the groundwater LOM under climate change, in which the red is for worst case of climate change, and blue show the best case of the climate change. I mean that when I use the best case of the climate change, I mean that the level of warming is the lowest level, is in the lowest level. So again, the increased water use efficiency increases the LOM and such this manner. Okay. Again, this is the level of management in groundwater during the observation period and under available water use efficiency. And these pictures show the level of management in groundwater under three scenarios of climate change. In the best case, the decreased level of management is about minus 0.30, and this is minus 0.57, and this is the minus 0.84. Again, we can see that the level of management reduced larger in greater or in worst case. And this is again for the level of management in groundwater under climate change, but under improved water use efficiency when compare each figure relative to the corresponding scenario. For example, in the best case, when compare the improved water use efficiency by the available water use efficiency, we can see that the level of management increases, but because increased water use efficiency leads to the lesser water loss during transporting, so we need to water supply less, and consequently the level of management increases in the region. Okay, this material is published in the Journal of Cleaner Production. Here I used the effect of another scenario in addition to the effect of climate change, which is address the effect of simultaneous change in land use and climate change. But I left this scenario for everyone to want to know more about this material. Okay, I thank you very much.
Thank you, Mustafa, for your lecture. Any questions for him? Any questions for Dr. Mustafa?
Out of river water level and groundwater level, which one more impacts the climate change?
Sorry, can you repeat your question again?
Just I want to know, out of, like you have mentioned, level of river water and also groundwater level, both impact the climate changes. I want to know which one more impact.
You want to know that the effect of climate change?
Yeah.
Okay, and but I cannot follow your question anymore.
Okay.
I'm pleased to explain your question in more detail. I could not follow your question thoroughly and completely because mm, my voice.
Okay, sir. Can you send me your email ID? I can ask that question.
Okay, if you have further question, can contact me via email.